All right, stats, welcome to your Chapter 13 Binomial Probability Distribution, Day 1 notes. I'm not with you today. I'm at a doctor's appointments with the young spawn that could simply not be rescheduled. So, on this first day back in the spring 2020, here are the notes you need to jot down. As you were told, how about that paper? How about a graphing calculator? Or really any scientific calculator. Any scientific calculator, because you guys should all have this somewhere on your calculators. Unfortunately, I can only show you with the TI-84 here, but it's easy to find elsewhere. In fact, on normal scientific calculators, it's easier to get to than it is on the TI-84 Plus. Everything on this paper, please write down, starting with Chapter 13, Binomial Probabilities. All right, don't worry about the binomial setting. Ask thoughts about binomial means two. Binomial, by, two, okay? Success or failure. That is what binomial is. Something either succeeds or it fails. All right, everything else, write down. Number one, there are a fixed number of observations. You're going to go to bat 20 times. There are going to be 31 days in July. All right, the observations are all independent. The first free throw has no effect on the second free throw. The third day of June has no effect on the weather on the, 8th day of June. Knowing the result of one observation does not change the probabilities we assign to the other observations. We've talked about that already with flipping a coin, spinning a spinner, and so forth. This is just using what we did in Chapter 10 and 12 and expanding it to this very important distribution that we will actually start talking about tomorrow. Each observation falls into one of just two categories. Yes, I'm going to go quick through this. There's an amazing little thing called pause on your video, which you can get all the notes, which we call success and failure. You make the shot or you don't. You get a hit or you don't. You make a sale or you don't. The probability of a success, call it P, is the same for each observation. If you're a 300 hitter, you're going to be that 300 hitter for all 20 at-bats. All right, then write this down. Binomial distribution. The count capital X of successes in the binomial setting has the binomial distribution with parameters N and P. The parameter N is the number of observations. How many at-bats are you getting? How many free throws are you going to shoot? And P is the probability of a success on any one observation. You know, probabilities are between 0 and 1. The possible values of X, again, that's the number of successes, are whole numbers. You can't make half of a free throw, and they go from 0 to N. Why 0? Because you could go 0 for 20 batting. You can go 0 for 5 at the free throw line. Why N? You could go 5 for 5 at the plate. You can go 25 out of 25 from the free throw line. All right? It is a discrete probability model. Why? Because all of our successes, number of trials, everything, it's all countable. 0, 1, 2, 3. No decimal, and it's finite. Okay? I will know the probability that I hit at least 17 out of 20 free throws. All right? It is a countable number. Both how many I hit and how many I can hit, my attempts, okay? So here's an example. Write it down just to think about. You are an 80% free throw. We've done this one before. Free throw shooter. And you're going to attempt 5 shots at the free throw line this game. What is the probability that you hit exactly, or that was the probability you make exactly 4 out of the 5 shots? All right, before we would have to do this quite a long way. All right, so come look here. Before, we would have to, I want to make exactly 4 out of 5. So I could make it, and write this down, I can make it every single time to begin with. I can make 4 straights and then miss one, right? I can make 4 straight and then miss one. And then, as you can probably suspect, because this doesn't say what's the probability you make at least 4 out of 5. This is exactly 4 out of 5. All right. I could make the first 3. Now, you guys should pick up on something here. I can make the first 3, miss the 4th, and then make the last one. That's just 0.20. It's just going to start at the end and always and just go up front. Then I could make the first 2, miss the 3rd one, make the last 2. This is the last time we will do it this way. Now we have the probability distribution. And we'll talk about its actual formula tomorrow. And then I could make the first one, miss the second one, and make the last 3. Notice how I will always have 0.8 to the 4th and 0.2 to the 1st. It's just how many of those will I have. And then lastly, I could miss the first one and then proceed to make the next 4. All right, so whatever that probability is, you know what we did. I don't really care too much about the answer. It's whatever 0.8 to the 4th power is times 0.2. It's 5 of those. You would add them all up. I want to know the probability that x equals 4. It would be the sum of all 5 of those. All right, so I have that down, and then lastly, let's look at example 2. You are still an 80% free throw shooter. Shooter, that is an R, believe it or not. And will attempt 10 free throws in a game? Holy cow. What is the probability you make exactly 8 shots? There's no way we would want to do this. All right, we want to do, you can make the first 8, miss the last 2. You can make the first 7, make it, miss it, make it. There are too many ways that can happen. So now we're going to introduce combinations. I want to know how many combinations of making 8 shots out of 10 could I have. There's 2 different things. There's combinations and permutations. A combination is when the order doesn't matter. Picking a committee of 8 people from 10. Making exactly 8 out of 10. It doesn't matter if you make the first 8 and miss the last 2. The order doesn't matter. Now, a permutation is when order matters. If I'm trying to figure out how many ways I could create a first, second, and third from 12 runners, well, first is better than third, second's better than third, so forth. If I'm trying to figure out how many ways I can name a vice president, president, secretary from a group of 5 people, that would be 5P3. The order does matter there, okay? For a lot of our all of our applications, order will not matter. So here's what I want us to do. I want us to figure out how to type that in our calculator. I want, on this one, 10C8. All right, 10 choose 8. That's what that means. And you're going to have to know how to say that correctly to me. 10 choose 8s. All right. From the 10 free throws, I want to make exactly 8 of them. So what you're going to do, if you have the TI-84, go ahead and look at it with me. All right, I got my calculator. I know the lighting's not great here, but you'll be all right. All right, that is on. What you have to do if you're using the TI-84 is you have to type in, again, I want 10 choose 8. So you need to type in 10 first. Type in 10. 10 is on my screen. Then you're going to go to math. Hit the button that says math. That button. Hit enter. I don't want math frac. I don't want number. I don't want maybe complex. I'm going to go over to probability. All the way to the right. PRB. And look at that. It's the third one, NCR. The second one is for a permutation, and the fourth one is, like 10 factorial and whatnot. We'll talk about that later, which is used. If you guys look, that factorial is used in this. But we can just go straight to math, PRB. Number 3, you guys are going to hit that one religiously. And then this is saying, all right, I want 10 in has to go in front. This is 10 choose. How many do I want to choose? I want to choose 8. So then I hit 8, 10 choose 8. I hit enter, and that's 45. All right, there's a formula for this that I will write on the board tomorrow for combinations and permutations. If you take more stats classes, you probably have to know to do that in your head, and you can. It's no big deal. It's just multiplication and a little elimination. There are 45 ways to make 8 out of 10 shots. Holy cow. Do you want to do, on the last one we just did 5 different scenarios, you would have 45 scenarios here. That's way too much. That's all, all right, so I'll actually go back here. So there are basically 45, write this down, there are basically 45 different ways to make 8 shots and miss 2. So if P is the probability of success, what do I want to do? I want 8 of them to go in. I'm going to have 0.8 to the 8th and 0.2 to the 2nd because I want to miss 2 of them. I'm going to have 45 of those. So what you're going to do is do 45 times, it's hard to do when I'm not looking. Nope, I don't want that. Okay, I got to look. 45 times 0.8 to the 8th. You'll notice that my calculator looks a little bit different. Times 0.2 to the 2nd. And the probability of making exactly 8 out of 10 free throws is 0.302. Holy cow, that was quick. So in that last one, we could have done exactly this as well, and I'll teach you how to do that tomorrow. Here's what I want you to do the rest of the time, folks. Write this down using your calculator. Let's talk about a scenario. What is the difference between from 8 choosing 3? Let's say I have 8 people to choose a 3-person committee. All right, in the committee, one title is not more important than the other. That would be 8C3. Versus, I've got 8 people, and now the committee has a president, a vice president, and a secretary. All right, so the order does matter. So choosing John for the president, Cindy for vice president, and Beth for secretary is a lot different than choosing Beth for president, Cindy for secretary, and John for vice president. Those are 2 distinctly different things. Whereas in a combination, choosing Beth, Cindy, and who did I say, John, it doesn't matter when order matters. That's just one distinct possibility. So what I want you to do, I want to type in 8C3. This is another way we're going to write it using this parenthesis. From 8, I'm choosing 3. We're going to use that all the time. So when I write 20 and 4, that is 20, choose 4. Anyway, everybody go to their calculator. I think the light's a little bit better here. And if I want 8C3, then I'm going to hit 8. I'm going to go to math, go over to PRB, hit enter, hit 3, and 8C3 is 56. So I'm going to write that down. That's the one I'm going to write down. I'm going to expect you know how to do this and how to say this and know that we're only doing combinations. So if you're sleeping today, which you will never do in the second semester, please know that we've already discussed this, all right? And I'm not going to answer that question. Mr. Jack, do I do a permutation? No. The only permutation we're doing is this one, and then that's it for this chapter. So 8P3 is going to have a big, it's going to have a different answer. I will show you that formula tomorrow, but we're not going to be using it. So I'm going to do 8. I'm going to hit math. I'm going to go down to this one, the second one. 8P3. There's 336 different ways when order matters. Okay? Big difference. We'll talk about why tomorrow. All right. For the rest of the time here, I want you to try those 3. Again, that is 20, choose 4. 31, choose 7. 25, choose 21. Write those down real quick. All right. In our calculator, I'm going to do 20. Hit math. You're going to do this a ton. PRB. Go down to 3, choose. Okay, we're not doing any more permutations. 20, choose 4. 48-45. How many ways can I get it exactly 4 hits and 20 at-bats? 4,845 different ways. Holy cow. Next one, 31, choose 7. All right, so say I want to know how many ways can I get exactly 7 rainy days in March? 31, math, go down to 3, 7. I don't know about you, but that is, you can see that number right away. That's over 2.6 million different combinations of 7 rainy days in the month of March, or July, or October, or December, or January. You get the point. Holy cow. And then lastly, 25, choose 21. And how many ways can you make 21 free throws? Exactly 21 free throws in 25 attempts. So, 25, choose 21. 12,650. Wow. Okay, a few things you should notice because this can save you some time. And let's be honest, time has not been our friend on quizzes and exams. So there's a few things we should know. 10, choose 1. 10, choose 1. I want to make exactly 1 shot out of 10 attempts. Let's see what this answer is going to be, and then I'll explain why that happens more tomorrow. So 10, choose 1 is 10. In, choose 1 is always in. 15, choose 1 is 15. 30, choose 1 is 30. So if you can have that down in your head, you can save yourself some time. Let's talk about 10, choose 9. Out of 10 free throws, I want to make exactly 9. What is 10, choose 9 going to be? 10, choose 9. Holy cow, it's 10 again. 15, choose 14 is 15. 20, choose 19 is 20. We'll talk more about why that happens tomorrow. Again, combinations and permutations have actual formulas within and are. We'll talk about tomorrow. And lastly, 10, choose 10. Now this one, if you think about it, and how many ways can I make exactly 10 free throws out of 10 attempts? There's only one way of doing that. It's knocking them all down. So when I type in 10, choose 10. In fact, we're not even going to write this down eventually because this would be bad. If you have to type this all in, that's silly, and we don't really know what's going on then. 10, choose 10. There's only one of those. How many ways can I make 15 free throws out of 15 attempts? That's you making them all. Whatever the rate of success is to the 15th power, okay? That should not be a mind blower. Anyway, folks, these are your notes. You need to have these down. You need to know what we're talking about because we're going to start with the actual formula tomorrow and go from there. This is an incredibly important chapter. This is huge. We're going to get at it early. Yak Math Videos signing out.